Welcome to the video tutorial for Unit 12, Acids and Bases. This is from Day 1. It was Tuesday the 3rd and Wednesday the 4th, for a red day. What we did today in the notes were pages 1 through 3, so look at that hard copy. We're acid naming and formula writing. So at the very beginning, please make sure you don't skip it. We're naming bases, which you already know how to do. Okay, so OH is going to be our important one that we use for bases. Bases always end in OH. And OH down here is hydroxide. Okay. So what we have is a metal and a polyatomic, so you just name it. Sodium hydroxide. Magnesium hydroxide. Copper needs a Roman numeral, so we'd say copper 2 hydroxide. Alright, naming bases are just like naming regular ionics. Naming acids aren't. Okay, naming acids are a little bit different. There are a couple of things you need to consider when you're naming acids. Okay, so the first thing is to know if it's an acid or a base. Okay, if it starts with an H, it's an acid. If it ends in an OH, it's a base. Okay, we'll learn Day 2, there's more to it than that, but for now, acid, acid, because they both start with H's, ending in hydroxides mean base, and base. Okay, so naming bases, just like we did up top, real easy. My polyatomic for base is always hydroxide. Okay, so I'm going to call it barium hydroxide. Manganese needs a Roman numeral, so uncrisscross to find this name. For HBr, this is one kind of acid. We've got binary acids, oxyacids. Remember in class. Binary acids have only 2 elements. Those are blank. So it's hydrogen and something else. So when I name binary acids, anytime it starts with an H, like these ones, I'm going to say acid at the end. Okay. Acid tells me that I have an H in the very front. So that's how I say H is my cation. H is my first thing, is by saying acid. So that means it starts with an H. Alright, so then to name the second thing. Because this is not a polyatomic ion, alright, so because this is just an element, because it's just one of these nonmetals, and it's not one of the polyatomics that we learned, it means it's binary. Bi, like a bicycle, 2 elements, 2 capital letters. Binary acids always start with hydro. Okay. Hydro doesn't tell me hydrogen. Acid tells me hydrogen. Hydro tells me it's not a polyatomic. So Br, we're going to change, instead of saying bromine, we're going to call it bromic. So ic, I-C, is going to be our suffix for most acids. Because if, like a lemon is very sour, it's acidic. Acidic things are sour. If you bit into a lemon, you'd go ick. Alright? So that helps us remember that bromine becomes bromic. Nitrogen becomes nitric. Oxygen becomes oxic. Fluorine becomes fluoric. Those types of things. Now this one has a polyatomic in it. I have 1, 2, 3 capital letters. So it's not a binary acid, it's an oxyacid, which means I do not start with hydro. You can only do hydro with 2 capital letters. So with a polyatomic, I won't say hydro. I'll just name that polyatomic ion. Okay, so remember when we're naming acids with polyatomics, we said there's no hydro. It just gets a polyatomic name. So I'm going to write this in 2 different colors so I can write over it. So I need to look up my polyatomic, which is everything after the H. So in this case, PO4. I'm going to look up PO4 on my table, and it's phosphate. Okay, so I'm going to write down phosphate, little here, O-S-P-H-A-T-E. And then in our notes, if you remember or if you were absent, you can check. We learned the phrase, oh, I ate too much, I feel icky now. Okay, I ate too much, I feel icky. Usually I told you you're not allowed to change anything on the polyatomic list. You copy it exactly, and that's always true except for acids. We can change phosphate, okay, the 8 part to ic. I'm going to call this phosphoric acid. And then phosphate, we learned in our rules, is a little bit of an exception. It gets spelt just a little differently. P-H-O-S-P-H. Instead of just IC, phosphoric, we're going to make it phosphoric if you forget the or and you just say phosphic, I'm not going to mark it wrong on a homework assignment, but on the exam I would call it phosphoric acid. Okay. So same thing on number 4, really similar. It's not a binary acid, so I won't say hydro because I've got 1, 2, 3 capital letters, which means I've got a polyatomic in here. And my polyatomic NO2 is nitrite, I-T-E. Okay. So I ate too much, I feel icky, was for endings in ate, I can change. For endings in ite, polyatomics in ite, I say bites, artilish, us. So ite becomes us. So instead of nitrite, I'm going to say nitrous acid. Nitrous acid. That's how we name. Okay. It's going to be a similar process down here. When we're looking, we've got H in front, which makes this one an acid. OH in back, which makes this one a base. This one's neither H in front nor OH in backwards, so it's a salt. Okay? Acid, salt, acid. Okay. That's page 1. Page 1 is mostly naming. You're given the formulas, you're asked to name. Page 2 then is the opposite process, where you're given the name and asked to write the formula. So, again, they want you to say acid, base, or salt. Names of acids are really easy to tell they're acids because it says acid right in the name, which is glorious. So hydroiodic acid is an acid. Acetic acid is an acid. Calcium hydroxide, OH, that makes it a base. Magnesium sulfide, it doesn't say acid, it doesn't say hydroxide, so this one must be a salt. Barium chloride, salt. Sulfurous acid, acid. Okay. So let's look at writing the formula. Start with salts because you know how to do that, and bases, you know how to do that. Okay. So this one, calcium. The 4 steps for writing formulas are you write the symbols. So calcium Ca, hydroxide is OH. It's a polyatomic, so I leave it in parentheses when I'm working. Calcium is in family 2, so it's going to make a +2 charge. Hydroxide, it says on my list, is always a -1. Okay, then I crisscross my 1 and my 2, reduce and erase. So my calcium gets an invisible 1. My parentheses stay because I have a 2 after it. CaOH2. Magnesium sulfide, same 4 steps. I write the symbols. Magnesium's Mg, sulfide is just sulfur. +2, -2, check your periodic tables. Crisscross, 2 and 2, reduce and erase. Since they're both 2's, they're the same, they get left off. Mg, S. That's unit 4, we've been doing that, oh man, like every week we've done some of this, either in Science Success or warm-ups or something. Okay, so that's not any different. Acids are going to be different. Same general process. So, the first thing I do, if I look at a name, it says acid, that tells me that the first thing in my formula is H+. Okay? Just like on this page, if it started with an H, I knew it was acid, so I said acid at the end. So seeing an acid tells me that it's H in the front. So hydroiodic acid, you write the symbols, just like I wrote the symbols here. Acid, which means H is my first symbol. Hydro tells me that it's a binary acid, so there's no polyatomics. Okay? So this is just going to be iodic is iodine, okay, which is I. H is always +1. Iodines in family 7A or 17, so it's -1. When I crisscross 1 and 1, my formula is just H invisible 1, I invisible 1, or high. Okay. Acetic acid. The acid tells me that my first symbol is hydrogen. Now there's no hydro in this name, so that means I must have a polyatomic here. Okay. And if I feel icky, remember our saying was, I feel icky. I ate too much, I feel icky now. So I need to go that way, which means acetic was actually acetate, A-T-E, which is this one. Acetic, like that, or acetate, A-T-E. So my second thing, I'm going to put parentheses, copied exactly here, C2, H3, O2, -1. Hydrogen is always a +1. So I wrote the symbols, I wrote the charges. Crisscross, 1 and 1. Reduce and erase. H, C2, H3O2, acetic acid. So for us acid, bites are to us. So this used to be sulfite. So it's hydrogen and sulfite is how we do that one. That's quick, fast and furious. Hopefully that's helpful. If you need more tutorials, come on in. We've got a quiz coming up. This is going to be a significant part of your final and of your Unit 12 test. So make sure we're feeling comfortable with naming acids. Thanks, guys.